Yo, what's up guys? Today we're gonna do LeetCode word ladder. So we are given a begin word and we're gonna do some transformations just that this word will become this word. And for each transformation you can choose like a character in this word. Let's say you choose H. You can make it another alphabetic character like from A to Z, like B. But the catch is that that new transform word has to be part of this word list. So let's say here we change H to become B. But it's not part of this word list, so this transformation is invalid. But let's say we choose I to become O, then hit will become hot, right? And hot is part of this word list, so this transformation is valid. And yeah, from this explanation here, you can see that they transform hit to becomes hot. But the catch is that there is no catch. I mean, we want to find the shortest transformation possible from hit to cop by doing those transformation steps. So I guess the first thing we can do is let's just convert this word list to become an order set, because a set has a better lookup time, right? Let's say we want to check if hit is part of this word list. If you do like a vector, you have to do character by character. I mean, not word by word. That is not constant time, but a set can help you look up where this word is part of this list in constant time. So yeah, let's convert word list from a vector to a set, right? That's how you do it. And yeah, the set is called words, whatever. And then this one is kind of like a decision tree, right? Kind of like a decision tree where you have like hit. You can have a couple of options. I think for hit you can only have one option, which is converting I to O. There's no other way of doing any transformation, just that hit will become another word except for hot in this list. But for hot, I think you have another option. You can have multiple options like H. You can make it so that it become L, and lot is part of this list. What about you change H to become D then? Yeah, dot. Dot is also in the list. So you have two options here. So it's kind of like a decision tree, right? But why breadth search? It's because you do it layer by layer. And let's say after some transformation you reach the final word clock here, you are guaranteed that these steps will be the shortest, right? Because you are not like picking like a word and you just keep going down forward. Maybe if you're choosing this path, it would take more steps, but because you're doing layer by layer, right? So once you reach the final word, just return the amount of step immediately. So this is guaranteed to be the shortest path, right? Okay. So for breadth search, you need a queue. Yeah, a queue string. Let's call it queue. Let's push the first word in, which is gonna be the begin word, and then yeah, let's traverse this queue. I mean this breadth search. This isn't tree. So while the queue is not empty, we can save the size of the queue as an n and do it as a for loop here, because we do layer by layer, right? So for each layer we only process the size of the queue, and then yeah, let's just pop the current value, the current string out of this queue. Okay, so have to do front first and then queue pop. So thing in C++, and then okay, now we're gonna enqueue some words in. How do we enqueue words in then? We're gonna, one way we can do this is like, let's say we are at the word hit, right? For each character, so let's do a for loop here. When j equal 0, j less than the size of the current word, you know, the good old stuff, j plus plus. Okay, so for each word in this, I mean for each character in this word, we're gonna replace this with like a character from A to Z, right? Yeah, so let's make another for loop. Say C, let's character from A, and C less than is equal to Z. That's we go from A to Z. In C++, characters like integers, so you can do increment operation as normal. Okay, so let's just replace H to be from A to Z, so it's A, B, C, D, E, whatever, right? So let's do this. Let's save it first. Let's save the current string. Let's make it a temporary, whatever, and then replace the character J, which is like the current position of this H here, 0, right? to becomes C, and then now it will become AIT for first iteration, right? And we're gonna check if it's the new transform word is part of this word list. So we can do words dot find current equal to words dot end. So you do it in C++. This one tells that, oh, it's part of the words list. This one is actually, yeah. If it's part of the words list, we just gonna enqueue it, right? So q dot push current words in, and yeah, that's it. And once you finish, you wanna change current back to the original word, so change from AIT back to HIT, and then keep going to the next steps, right? We're just gonna I here, and I is gonna be from A, B, C, D, E, F, G again from this for loop here. Yeah. And once we finish this this our for loop here, our queue now we have hit is being popped out, so it's gonna be hot. Yeah, because we know the hot is part of this word list. Okay. And yeah, let's have another integer. We're gonna call output. Keep track of the number of steps we have taken. So whenever we process this queue here, that's a layer, which is gonna be a step, right? So we just increment the output. And here, when we pop, we essentially want to check if this current word is the end word, right? Let's see if we have found the transformation that leads to this end word. If we found it, simply return the output. Yeah, if not, keep processing as usual. And yeah, we are guaranteed that we will have this transformation. I mean, no, there's no guarantee. My bad. So we return 0 if it's not possible to transform from begin to end. Okay, so we return 0 here. But if we found a path, we return it here. Okay. This one looks good then. Am I missing anything? I guess not. So let's give this code a run. That is slower than I thought. Oh, what happened here? Get a size, give it a push, get a pop. Yeah, looks good to me. I don't know what happened there, not gonna lie. Okay, sorry guys, this is what I'm missing. So let's say this is the word list. This is our current queue. We just push hot in, right? When we push hot in, we don't want to consider hot next line, right? So we want to erase it from our word list, so that next time, let's say we just process hot and we look at this word list. If hot is still here, we are gonna add hot in again. So it's gonna be an infinite loop, you know what I'm saying? So when we process a word, just remove it from the list. And how we do that in a set, just do word dot erase current word. And that's also why we want to use a set, right? Because remove in an element in a set is also a constant time operation. It's way more efficient than a vector. Okay, we got accepted. Let's submit it. Awesome. And that is word ladder. Thanks for watching, guys. If you have any problem you want me to solve, just leave in the comments. Alright, see you guys.